بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Math grade 9 Algebra 1. We are in Model 4 Lesson 5 Arithmetic Sequences. Arithmetic Sequences. So in this lesson we want to learn arithmetic sequences. What's the meaning of a sequence? A sequence is a set of numbers that are ordered in a specific way. Each number within a sequence is called a term of a sequence. And in an arithmetic sequence, each term after the first is found by adding a constant, the common difference d, to the previous term. So, what the meaning of an arithmetic sequence is a numerical pattern that increases or decreases at a constant rate called the common difference. Example, as you see, we have 22, 17, 12, 7, 2, etc. This is sequence. Each number, the name of each number here, term. This is term of sequence, term of sequence. As you see, 22 minus 5 equals 17. 17 minus 5 equals 12. 12 minus 5 equals 7. 7 minus 5 equals 2. The name of minus 5 or negative 5, this is the common difference. This is the common difference. Represent D. Represent D. And as you see in this example, we have negative 13, negative 5, 3, 11, 19, etc. Negative 13 plus 8 will be negative 5. Negative 5 plus 8 will be 3. 3 plus 8 will be 11. 11 plus 8 will be 19. So as you see here, the common difference, D equal 8. D equal 8. Identify arithmetic sequence. Determine whether the sequence is an arithmetic sequence. Justify your reasoning. We have this sequence 17, 14, 10, 3, 7, 3. So as you see here, 17 minus 3 equal 14. 14 minus 4 equal 10. 10 minus 3 equal 7. 7 minus 4 equal 3. So as you see here, minus 3 minus 4, minus 3 minus 4. So this sequence doesn't have a common difference because here negative 3, here negative 4. Between its term. So this is not an arithmetic sequence. This is not an arithmetic sequence. In this example, determine whether the sequence is an arithmetic sequence. Justify your reasoning. So as you see here, 82, then we have 73. Then we have 64. Then you have 55. So as you see here, 82 minus 9 equals 73. 73 minus 9 equals 64. 64 minus 9 equals 55. So here we have the common difference, D equal 9. So means that yes, there is a common difference of negative 9. Negative 9. So means this is arithmetic sequence. Find the next term. Find the next term. Determine the next term, the next three terms in the sequence. We have this sequence 11, 7, 3, negative 1. So at the first, find the common difference. As you see, 11 minus 4 will be 7. 7 minus 4 will be 3. 3 minus 4 will be minus 1. So D equal negative 4. D equal minus 4. Then add the common difference to the last term of the sequence to find the next term. The last term here, as you see, negative 1. Negative 1 plus negative 4 will be negative 5. Then take negative 5 plus negative 4 will be negative 9. Then take negative 9 plus -4 will be 13 or -13. In this example, determine the next three terms in the sequence. We have, as you see here, 31, then we have 18, then here we have 5. So what is the common difference here? What is the value of D? 31 minus what equal 18? 18 minus what equal 5? Minus 13. So 31 minus 13 equal 18. 18 minus 13 equal 5. Now how to find the next three terms? 5 minus 13 will be minus 8. Minus 8 plus minus 13 will be minus 21. Minus 21 plus minus 13 will be minus 34. The second idea, arithmetic sequence as a linear functions. Each term of an arithmetic sequence can be expressed in terms of the first term a1 and the common difference d. So the nth term of an arithmetic sequence with the first term a1 and common difference d is given by this rule. an means the nth term equal a1 means the first term plus n minus 1, the number of terms inside the sequence, minus 1. Multiply by d, d means the common difference. So the graph of an arithmetic sequence includes points that lie along a line because there is a constant difference between each pair of points. The function is linear for the equation of an arithmetic sequence an equal a1 plus n minus 1 multiplied by d. So n is the n-dependent variable. N is the n-dependent variable. an is the dependent variable. And d is the slope. d is the slope. So the function of an arithmetic sequence is written as fn equal a1 plus n minus 1 times d, where n is a counting number.
Mister, can you invite Joke?
In this example, find the nth term. Find the nth term. Use the arithmetic sequence. We have here -4, -1, 2, 5, etc. to complete the following. So we want to use this rule. We want to use this rule to find the nth term. So an. What is the first term a1? a1 will be what? Will be -4. What is the common difference? The -4 plus what equal -1? Plus what equal 2? Plus 2 plus what equal 5? Plus 3. So d here equal 3. d equal 3. So we can write here a1 -4. And here n minus 1 and here 3. So we can write here we have a n equal a1 means the first term plus n minus 1 multiplied by d. And we have the sequence here minus 4, minus 1, 2, 5, etc. How to know A1? A1 means the first term in the sequence, negative 4. How to know D? D means the slope or the common difference. From negative 4 to negative 1, we have 3. From negative 1 to 2, we have 3. From 3 to 5, from 2 to 5, we have 3. So means D equal what? D equal 3. Then substitute the values in the function rule here. An equal A1 means negative 4 plus n minus 1 multiplied by dd d equal 3 multiplied by 3. So we have here negative 4, and here we can use distributive property. 3 times n will be 3n. Then 3 times negative 1 will be negative 3. Then combine the like terms, add the like terms. We have here 3n, and negative 4 plus negative 3 will be negative 7. So an equal 3n negative 7. An equal 3n negative 7. Then find the 16th term of the sequence. Put the value of n 16. Put the value of n 16. So use the equation from part A to find the 16th term in the arithmetic sequence. So an equal 3n minus 7. Substitute the value of n 16. Then you can express this expression. 3 times 16 will be 48. 48 minus 7 will be 41. So a 16th term will be 41. Will be 41. Randy has been training for a marathon, and it is important for her to keep a constant pace. She recorded her time each mile for the first several miles that she ran. 1 mile here, time was 10 minutes and 30 seconds. And 30 seconds means the half of 1 minute, means here 10 minutes and half. And here 2 miles, here time was 21 minutes. Then 3 miles, here times was 31 minutes and half. 30 seconds means the half of the minute. At 4 miles, here times was 42 minutes. So as you see here, we have 10.5. If you add 10.5 plus 10.5, you will get 21. 21 plus 10.5, you will get 31.5. 31.5 plus 10.5, you will get 42. So the D here equal 10.5. So the equation will be Fn equal 10.5 n. How long will it take her to run a whole marathon? Round your answer to the nearest thousands if necessary. A marathon is 26.2 miles. So we can substitute here 26.2, and you can multiply, you will get 4.585 hours. In this example here, as you see here, we have current balance as of 3/1/2019, $690. And here the balance 635, and here 580, and here 525. So create a function to represent the sequence. So here we have the sequence 525, 580, 635, 690. As you see here, the common difference or the value of the d will be 55. So the first find the common difference. 525 plus 55 will be 580. 580 plus 55 will be 635. 635 plus 55 will be 690. So the common difference is 55, or the value of d equal 55. The balance after 1 month is $580. So let A, this is the first term, let A1 equal 580. Notice that the starting balance is 525. You can think of this starting point as A0 equal 580. So write the formula Fn equal A1 plus n minus 1 times D. A1 equal 580, sorry, plus between parentheses n minus 1 times the value of D will be what? 55. You can use distributive property here. Rewrite here 580 plus 55 times n, 55n. 55 times negative 1 will be negative 55. So add the like terms. 580 minus 55 will be 525, and here we have 55n. Part B, graph the function and determine it is a domain. And here we have n, this is the domain, and here we have fn, this is the range. If we have n0, put here 0. 0 times 55 will be 525. So this is the first point. 0, 525 will be here. If you have the value of n1, 1 times 55 plus 525 will be 580. So the second point, 1, 580. This is the second one. If you have n equal to 2 times 55 plus 525 equals 635. So the third point will be 2, 635 will be here, etc. If you represent the all points here, as you see, you will get linear. You will get linear. So the domain is a number of months. Since Linkia opened her savings account, so the domain is 0, 1, 2, 3, 4, 5, 6, and the range will be 525, 580, 535, etc. So this is our lesson for today. Who has any question about these ideas? Are all ideas clear for all? No questions? Everything is clear for all?
Yes.
Okay. So what is our lesson today? Arithmetic sequences. Arithmetic sequences. In this example, determine whether each sequence is an arithmetic sequences. Justify your reasoning. Who can tell me? Number 1, is it this sequence arithmetic or not? As you see here, from 11 to 6, we have minus 5. From 6 to 1, also we have minus 5. From 1 to minus 4, also we have minus 5. So here we have the same number, the same common difference, or the same slope. So means yes, this is arithmetic sequence. Right. In this example, who can tell me this is arithmetic or not? So from 3 to 5, 3 plus 2 equal 5. 5 plus 3 equal 8. 8 plus 4 equal 12. So here we have 2, here we have 3, here we have 4. Means we have different common difference, different slope. So means no, this is not arithmetic. This is not arithmetic sequence. So who can tell me here in this exercise, is it this sequence arithmetic or not? As you see here, 40 minus 20 will be 20. 20 minus 10 will be 10. 10 minus 5 will be 5. So here we have minus 20, here we have minus 10, here we have minus 5, means we have different slope. We have different common difference. So it means no, this is not arithmetic sequence. Okay, here, who can tell me here, arithmetic or not? As you see here, 0 plus 1 over 4 will be 1 over 4. And 1 over 4 plus 1 over 4 will be 1 over 2. And 1 over 2 plus 1 over 4 will be 3 over 4. So here we have the same slope. We have the same slope. We have the same common difference. So means this sequence, yes, arithmetic sequence. In the second example here, find the common difference of each arithmetic sequence, then find the next 3 terms. Right. As you see here, we have minus 11. Minus 11 plus 6 will be minus 5. Minus 5 plus 6 will be 1. 1 plus 6 will be 7. So it means here D equal 6. How to find the next 3 terms? Take the last term 7. 7 plus 6 will be 13. 13 plus 6 will be 19. 19 plus 6 will be 25. In this example here, 5 minus 10 will be minus 5. Minus 5 minus 10 will be minus 15. Minus 15 minus 10 will be minus 25. So it means here D equal minus 10. How to find the next three terms? Minus 25 minus 10 will be minus 35. Minus 35 minus 10 will be minus 45. Minus 45 minus 10 will be minus 55. In this example, use the given arithmetic sequence to write an equation and then find the seventh term of the sequence. For example, here 14. And at the first step, find the common difference or the slope, the value of D. Here we have 8, then we have 2. Means 8 minus 6 equal to 2 minus 6 equal minus 4. Minus 4 minus 6 equal minus 10. So means D equal minus 6. Then what is the first term in this sequence? A1. The first term, as you see here, we have 8. Then you can write the rule. AN or FN, the same idea. Equal A1 plus N minus 1 between parentheses times D. Then substitute the values. A1 equal 8 plus N minus 1 multiply the value of D equal negative 6. So here we have 8. Then here you can use distributive property. Take negative 6 times N will be negative 6N. Negative 6 times negative 1 will be plus 6. Then combine the like terms. Here we have negative 6N. And here 8 plus 6 will be 14. So it means AN equal negative 6N plus 14. This is the equation. Now find the seventh term. So A, the value of N now equal what? Equal 7. A7 equal negative 6 times the value of N will be 7 plus 14 negative 6 times 7 will be negative 42 plus 14 equal negative 28. طيب. Who has any question about these ideas? Are all ideas clear for all? No questions? No questions, girls?
No.
Okay. So this is video for today. Thank you for your listening. Have a nice day. See you tomorrow, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.